Alright, here's your homework for solving logarithmic equations. When we have a log equaling another log and the bases are the same, you can take what's inside the logarithm and make them equal to each other. And then when we solve it, I'm going to subtract 6. So 9, 6, take away 6 is 3. I'm going to add 5. So 4 plus 5 is 9. And then divide. What we have to be careful of is that when you plug it back in, the answer cannot be negative, that part inside. So when I plug 3 back in for A, it's a good answer, but I need to check to make sure the logarithm, the answer part, is not equal to a negative number. That's what makes it extraneous. All right, number 2. So when the bases are the same, I can multiply to put them together, and then I just have 4x subtract 8. And then expand, combine like terms. So 6 subtract 4, add 22, take away 8, that's 14, and then divide and you get 7. Again, check. 7 is a good answer. The logarithms would be positive inside. Here we have ln, so when we're subtracting, we're dividing. So we have m plus 3 divided by 2m minus 1, and that's equal to 4. So if they have all the same base, I'm just focused on what's inside. I'm going to multiply both sides here by 2m subtract 1. That leaves me with m plus 3 and 8m subtract 4. Combine like terms. Add 4 and you get the answer 1. So when I plug 1 in, make sure that it fits, that we don't have a negative number inside the logarithm. Here, again, the bases are the same, so we can take what's inside and make them equal to each other. It's a quadratic, so we're going to make it equal to 0. So I'm going to subtract 1p squared, and we have 3p, and subtract 10. We're going to factor it. So the two numbers that factor are 5 and negative 2. So we have negative 5 and positive 2 as my answers. If I put in negative 5, or if I put in positive 2, both give me positive answers inside, and they both work. Number 5 here, this quarter actually belongs as the exponent here. So that's the fourth root. So we have the fourth root of 16 q to the 8. Subtract means you divide it by 3, and it's equal to 24. So I'm going to multiply by 3. Alright, so I'm going to multiply by 3. That gives me 72. The fourth root of 16 is 2, and 8 divided by 4 is q squared. So I can simplify that. Divide by 2. Half of 72 is 36. And then the answer could be positive or negative 6. And negative 6 is okay because negative 6 would be plugged in and have a even exponent. So it's a good answer. Here, subtracting means I'm dividing. I'm going to multiply both sides by negative 2y subtract 3. So 6 is equal to negative 8y subtract 12. And then add 12 and divide. That's not it. Add 12 is 18, and then divide. So when you divide, you get 18 over negative 8, or negative 9 over 4. When you plug a negative number in here, this takes a bit to think through. A negative times a negative would be 18 over 4, which would be bigger than negative 3, so it'll give you a positive answer and still work. Number 7, we have that base, so it's 3x plus 12. For this, remember subtracting means we are dividing, and then that's all to the exponent 3/4. So we have a little work to do on the right side. So 5 goes into 40, 4 and 5 evenly. That'd be 81. The fourth root of 81 is 3, and 3 cubed is 27. So again, the fourth root of 81 is 3, and 3 cubed is 27. Subtract 12 and divide, and you get the answer 5, and it's a good answer. Bases are the same, so when I'm adding, I'm multiplying, so W12 times W, and then this would be 4 to the exponent 3. So I have W squared plus 12W is equal to 64. Subtract 64, factor it. The two numbers that multiply to 64 and subtract to 12 are 16 and 4. So one answer is negative 16 and the other answer is 4. Negative 16, if I put that inside the logarithm, negative 16 plus 12 gives me a negative answer inside. So that's no good. That's extraneous. This is the only answer that works, positive 4. Turn the page. Here, we're going to write it exponentially to solve it. So, in this example, the base is 6, the exponent is 3, and the answer is 11p plus 18. So that is 6 times 6, 216, right? And then subtract 18, and then divide by 11. It actually goes in evenly, 18. Is that a good answer? Yeah, it gives you a positive number inside the logarithm. Here, we're first going to isolate the logarithm. So we're going to divide by 2. Then we're going to write it exponentially. So what's inside, we can go the other, I think it's easy to go the other way. So what's inside the logarithm is the answer, 3x subtract 7. The base is 2, and the exponent is 5. So 2 to the 5 is 32. Add 7. Divide by 3, and you get 13. Again, that's a good answer when you plug it back in. Number 11. First, we're going to isolate the logarithm. So we're going to subtract 3. Then, for this logarithm, the base is e, the exponent is 2, and the answer is 4u. To get u by itself, you divide by 4. To me, that's a good answer. E squared divided by 4. If you put that in your calculator, or e is in your calculator, you could do that one too. So if I wanted to know the approximate answer, e is here in yellow, right where the x is. So right where the x is, e to the x is in gold, it's in yellow. So press diamond x, and you get e, so it's e to the 2, and then I'm dividing that answer by 4. So it's 1.847. Now, on this calculator, e just sticks out right there to you, right? It's like right there on the left. So you just press the same thing. You go e to the 2 and then divide by 4. And you get the same answer. So e to the 2 divided by 4, same answer. All right, here I want to isolate the logarithm, so it makes more sense to me to multiply both sides by 2 to do it. I could write it as an exponent, but that's not going to be helpful. So times 2 both sides, that's 4/3. Now write it. The answer is 5c plus 6. The base is 27. The exponent is 4/3. The cube root of 27 is 3, and 3 to the 4 is 64. No, it's not. 3 to the 4 is 81. And then subtract 6, and then divide. and you get 15. 15 is a good answer. Here, divide by 2. 0 divided by 2 is 0. The answer is 2a minus 1. The base you don't see is 10 to the exponent 0. So that's 2a subtract 1 equals 1. Add 1 to 1. Divide. And when you plug 1 in, it's a good answer. 14. So to combine this together, I'm going to multiply. So 2 times k minus 4. And then the base, what's inside, is 2k minus 8. The base is e to the 1/3. And then the exact answer would be e to the 1/3 plus 8. And then divide all of it by 2. That's a great answer. If I wanted to know the approximate answer, I just would have to type it in. Now, if I'm going to type it in, I got to use parentheses. So it's e. Now, 1/3 is just 1 divided by 3. And then plus 8. Then close the parentheses for the numerator, and then divided by 2. And then you have your answer. So it's 4.698. All right, 2 more. Can you solve this logarithm? So subtracting means that I'm going to divide. So it's 2w divided by w plus 3. And that's equal to 3. So the answer is there. And then the base is 2 to the exponent 3. I'm going to multiply both sides by w plus 3. So we have 2w squared is equal to 8w plus 24. I'm going to divide, it's a quadratic. I'm going to divide everything by 2 to make the numbers a little smaller. I'm going to make it equal to 0, so I'm going to subtract 4w and subtract 12. So that it'll be w subtract 6 and w plus 2. So the two answers I'm looking at are 6 and negative 2. And both of those work inside my logarithm. Last one. So I'm going to write this as one logarithm. So I have n plus 14 times the square root of 4n squared, because the exponent 1/2 means square root, equal to 2. So before I write it exponentially, I'm going to clean up what's inside. So the square root of 4n squared is 2n. Now what's inside is actually 2n squared plus 28n. And the base is 12. And the exponent is 2. That's 144. Divide everything by 2 just to reduce it down. Make it equal to 0. So subtract 72. Then you have to factor it. What two numbers multiply to 72? And subtract to 14. It's a bit tough. It's 18 times 4. So positive 18 and negative 4. So the two answers are negative 18 and positive 4. Negative 18 is no good, because negative 18 plus 14 is a negative inside the logarithm. So the only answer there is 4. All right, GMAT out. Good job doing your homework.